Hello students, welcome back to Sneha Sopti YouTube channel, and today we shall be doing a topic which is very helpful for grade 11th, 12th, CPSC, ISC, IB curriculum, and especially for the competitive exams as well in cracking, because the basic concepts of periodic table, the ionization energy trends of the transition elements, which is the D block elements, will be explained. If you are new to my channel, kindly subscribe my channel and click on the bell icon so that you can get the notification at the earliest. Now, so when we move on, that what is ionization energy? First, we should know that what is ionization energy. Ionization energy is represented by the symbol IE, in which we do write as capital I dot capital E, or we can say it as ionization enthalpy. So the symbol is ionization energy. Ionization energy is defined as the amount of energy required to remove the electrons from the outermost shell of an isolated gaseous atom. So such type of energy is called ionization energy. Before we do what factors are there which affect ionization energy, please do watch this video till the end, because many of the questions which are asked in the competitive examination, JEE, NEET, they are covered by my explanation. Now, first of all, if we move to the transition elements ionization energy, we should first know that what is the D block element general electronic configuration. Now, when we talk about the general configuration, the elements in the D block, the electrons which are adding up, they're adding up in the penultimate shell, which is N minus 1. That is the penultimate shell, and the electrons enter from 1 to 10 and then NS 0 to 2. Please remember, this N minus 1 shell is called penultimate shell. This is one of the basic. Do remember this electronic configuration, because in the form of MCQs, they do ask general configuration of D block elements or any block element. Now, before moving on much, we do one concept like screening effect. And one of the question which is mostly asked for the screening effect is arrange S, P, D, F orbitals in the increasing order of their screening effect. What is screening effect? The repulsion between the inner shell electrons, which keeps the nucleus slightly away from the effect of the outer shell electrons. That is called the screening effect. So maximum screening effect goes for S, P, D, and then F. This is the increasing order of screening effect. That maximum screening effect is for S, P, D, and F. So do remember that S being nearer to the nucleus, so being nearer to the nucleus, it will shield away the nuclear charge. That means it will offer the maximum screening effect. Repulsion between the electrons is called screening effect. So now, before moving on ahead with the ionization energy concept, I just let you know about the 3D trend, 3D series trend of the atomic size. If I write about the 3D series, that is, I give you an abbreviation, star, TV, cable, May, Phi, Co, Ni, Ku, Zinc. This is the 3D series elements, the first transition series. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. You all know their atomic numbers as well. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. That means atomic numbers are increasing. So nuclear charge will be increasing. So atomic size should decrease as we go along the period. The general trend must be that atomic size must decrease as we go along the period from left to right in the periodic table. But what happens from scandium to manganese, it is observed that the atomic size decreases. Then for this triad, iron, cobalt, nickel, the atomic size remains almost the same. And as we move from copper to zinc, the atomic size, instead of decreasing, it increases. Now, what happens for manganese and iron? For manganese and iron also, the atomic size is almost similar. So now, why is this general trend? Atomic size basically depends upon 2 or 3 factors. Like one is the effective nuclear charge and the screening effect. As we move along the period, now I'm giving you the explanation from scandium to manganese. This explanation is related to scandium to manganese. Atomic number is increasing. So Z effective means effective nuclear charge is increasing, and that is greater than the shielding effect. The repulsion between the electrons is also offered, but in this case, the shielding effect is more than the nuclear charge. When we go for manganese to iron, or when we talk about iron, cobalt, nickel, this triad, why the atomic size is same? Because the effective nuclear charge is almost equal to the shielding effect. This has all been studied and observed. So we have to just remember why their sizes are same in spite the atomic number is increasing. So this is the explanation that effective nuclear charge is almost equal to the shielding effect. Now the question comes for copper and zinc. Atomic number is 29, 30. So why atomic size is increasing? The reason is that when we write the configuration for copper, so it will be argon 3D10 and 4s1. And if I write for zinc, it will be argon here the 18 electrons completed, 3d10 and 4s2. The orbitals are satisfied here, half filled, fully filled, extra stability, electrons more. And it is observed that the screening effect is more than the effective nuclear charge. So I hope I'm clear with it. The copper and zinc has more atomic size. First basic factor is the stability of the d orbitals, and we can say the effective nuclear charge is not as much because of the increase in repulsion between the electrons. This is important for me to explain you related to the ionization energy. So I have that. So please remember, for the atomic size from scandium to manganese, atomic size decreases. Manganese iron almost same. From iron to nickel, same size almost. And then from copper to zinc, it gradually increases. So the trend in the decrease, then increase, it's not regular. Now we will move to the actual topic, trend in the ionization energy of d block elements as we go from left to right in the periodic table, which is very, very important. If here also I talk about ionization energy, it depends basically on many factors, but today we will study the factor as effective nuclear charge. If the nuclear charge is more, definitely ionization energy is more. Then it depends upon atomic size, or we can say atomic radius. Atomic size, ionization energy are inversely proportional. Ionization energy is inversely proportional to atomic size, or you can say atomic radius. More the atomic size, that means electrons are far away from the nucleus. It is easy to pull the electrons from the outermost shell, so ionization energy will be less. One is the screening effect. Same, if the screening effect is more, repulsion between the electrons is more, then we can say that ionization energy would be less because repulsion between the electrons is more and more and more. So that means they are moving far away from the nucleus. So it is easier to remove the outermost shell electron. And I will be also doing one as exchange energy. Now, what is this exchange energy, which is also called the reorganization energy? If we talk about the D block elements, so exchange energy is directly proportional to the number of unpaired electrons. Greater the number of unpaired electrons, greater is the exchange energy and greater is the ionization energy. Ionization energy is directly proportional to exchange energy. See, what does exchange energy means? Now, suppose if I take up an example like of 3D series first and I write down the series star, TV, cable, may, phi, o, ni, u, zinc. I take up two elements. Suppose I take up manganese and I take up vanadium. Their atomic numbers are 21, 22, 23, 24, 25 and so on up till 30. Vanadium electronic configuration will be argon 3d3 4s2. And if I talk about manganese, the configuration will be argon 3d5 4s2. Now, if I draw this is 4s orbital and this is the 3d3. In 4s, there are 2 electrons and in D, there is 1 electron. Similarly, in manganese, if I talk about 4s, there are 2 electrons and in D, there are 5 electrons. 1, 2, 3, 4, 5 in the same spin. And when we do the pairing, that is in the opposite spin. Now, what is this reorganization energy or the exchange energy? When there is the presence of unpaired electrons, what happens? S and D are nearer to each other, so they start jump into each other's orbital. That means they are starting to reorganize themselves. So this amount of energy which is released, that is the reorganization energy. Same way for this, for this, for this, for this, and so on. So greater the number of unpaired electrons, greater is the exchange energy and greater is the ionization energy. So if I say from scandium to manganese, if I move, the unpaired electrons are increasing. So ionization energy also increases. Secondly, we know that atomic number is increasing. So Z effective is also increasing. Z effective is also increasing. Effective nuclear charge is also increasing. Exchange energy is also increasing. That is why as we go from scandium to manganese, ionization energy increases. I hope I am clear with this concept. Now, if we go from iron to nickel, because their atomic sizes are almost the same, so ionization energy is also almost the same. Now, for copper and zinc, ionization energy also increases because previously also I've explained because of the presence of the fully filled d orbital, there is an extra stability. If I say 3d10 4s1 and if I talk about copper, it is argon 3d10 4s2. Sorry, not for copper, it's zinc. 3d10 4s2, fully filled, extra stability, large amount of energy is required to remove the electrons. So always remember half-filled orbitals and fully filled orbitals have an extra stability. When we have done how is the irregular trend for the ionization energy of the first transition series, which is the 3D series. Now a most important question which could be asked in the boards as well as in JEE, that if I compare the first ionization energy of chromium and the first ionization energy of manganese, which will be greater? This is the first ionization energy. First ionization energy means the amount of energy required the one electron from the outermost shell. So it is observed that the first ionization energy of manganese is more than the first ionization energy of chromium. Why? That is all because of the configuration. The chromium configuration is argon, that means 18 electrons over 3d5 and 4s1. Whereas that of manganese with an atomic number of 25, it has the configuration as argon 3d5 and 4s2. Can you see for manganese the s orbital is completely filled, extra stability, and that is half filled. So manganese does not want to be But manganese does not want to easily lose its electron to become unstable. But manganese and chromium, if we consider for the first ionization energy, due to an extra stability of the completely filled s orbital and the half filled d orbital, the ionization energy of manganese, first ionization energy of manganese is definitely greater than the first ionization energy of chromium. Now the twist comes when we talk about the second ionization energy. First ionization energy means one electron has been lost. So manganese will be converted as then manganese ion. So that will be 3d5 and 4s1. This is, manganese ion. And if I talk about, this is the first ionization energy, and after this is formed. If I talk about chromium, when one electron is removed, the configuration shall be argon 3d5. Now for the second ionization energy, when we have to remove one more electron from the outermost shell, that means it's chromium ion, and here it is for the manganese ion. So definitely ionization energy 2 of chromium ion will be greater than ionization energy 2 of manganese. Why? Because now the chromium ion has the configuration argon 3d5 and manganese ion has the configuration of argon 3d5 4s1. So this one electron can be removed easily as compared to this 3d5 electron, because this chromium ion is now half filled, extra stability. If one electron is removed, it will be changed to 3d4. So why chromium wants to be unstable? Chromium doesn't want to be unstable. So large amount of energy will be required to remove this one electron from the d orbital. That means this is the reason that why second ionization energy of chromium ion is greater than that of the manganese ion. Same way, if you talk about the ionization energy 1 for copper and ionization energy 1 for zinc. So that is greater than that of copper. The reason is that the first ionization energy of zinc, if we talk about the zinc being atomic number 30, will be having the configuration 3d10 4s2. Fully filled, fully filled. Copper has the configuration argon 3d10 4s1. Due to the extra stability of completely filled orbitals, the first ionization energy of zinc will be greater than that of copper. Now, when one electron is removed, zinc will be changed to argon 3d10 4s1, that is zinc plus ion. And for this, when one electron will be removed, it will be copper plus ion. So the configuration will be argon 3d10. Now, if I talk about ionization energy second, that means when copper has changed to copper 1 and zinc has changed to zinc plus 1. So definitely second ionization energy of copper plus will be greater than that of zinc plus, because now there are d10 electrons completely filled. If one more electron will be removed, it will be turning into an unstable 3D9. So copper plus doesn't want to be unstable. That means very large amount of energy will be required to remove the one more electron. Whereas if I talk about zinc, it will be very easily removing this s electron and changing into argon. If one more electron is removed, that changes into argon 3D10. Now extra stability of zinc plus. So first ionization energy definitely for zinc is greater than the first ionization energy of copper. If you have any confusion, please rewind this video. You will be able to understand. And the second ionization energy of Cu plus ion will be greater than that of zinc ion. For this particular, all the questions which could be asked related to ionization energy trend for the 3D series has been completed, done by me. Now, one more question which could be asked related to competitive as well as board point of view. Ionization energy of D block elements is definitely greater than the ionization energy of S block elements. Greater atomic number, greater effective nuclear charge, so greater ionization energy. That means if ionization energy is more, large amount of energy is required to convert them into an ion. So the reactivity will be reduced. So the reactivity of D block elements is definitely less than the reactivity of S block elements. I hope this is clear. One simple and the basic topic which I shall do with you right now. We know that the 3D series, I give you an abbreviation earlier also, star, T, V, cable, may, Phi, Co, Ni, Ku, Zinc, 21 to 30. This is the 3D transition series. If I talk about 4D transition series, that starts with yttrium, U, Zara, zirconium, ना बनो, मानो तुम्हारे रूप, रंग, पे, अजी, कह दिया. So in this way, an abbreviation, a simple abbreviation, if you want to mold into another, it's all up to you. Now, 5D transition series, zinc, cadmium, just remember this. This is mercury, copper, silver, and then remember as gold. These are some of the metals. Nickel, palladium, platinum. Now, I move from back to this for the abbreviation. There is one a saint called Oso. So, Ishwar, Oso, Rajneesh, winter, just tungsten, winter, tak, half, late. This is the lanthanide series which we'll study in the F block. So we basically consider till here. And the 6D series which starts with the actinium, that is an incomplete series. We know down the group ionization energy decreases because of the increase in atomic size. But it is considered that the ionization energy of 6D series is greater than the ionization energy of 5D series, because in the 6D series when we do the configuration, the electrons will be filling up in the 4f orbital, then it fills in the 3D and then in the 4s. So because of the filling of the electrons in this 4f orbitals, which means it has less shielding effect, f orbital has less shielding effect and more effective nuclear charge, due to which ionization energy of the 6D series is greater than the 5D series. I hope I have cleared the concept well. Any doubt, please rewind this video and look out. And still more doubt, please write down in the comment box so that it could be explained well to you. So thank you for watching this video and continue having a happy, enjoyable learning. Link for my YouTube channel shall be written in the description box.